right, part D. What is the concavity of the graph at x equals 0.5? So concavity means I need to look at the second derivative, which, let's write it again because it's off the screen. The second derivative is 2x cubed minus 18x squared plus 42x. Okay, so if I want to talk about concavity, I look at the second derivative, which I did, and I'll plug in the point to figure out what's happening at that exact point. Okay, that ended up really ugly. There we go, much better. Okay, so I'm plugging in 0.5. And again, this looks like something I would need a calculator for. It's always good to try mental math, but when fractions are involved, I'm usually kind of out. All right, 0.5 cubed is 0.125. And then 0.5 squared, I believe, is 0.25. Oops. And then plus 42 times 0.5. All right, so 42 times 0.5, that's 21. 18 times 0.25, 4.5. 2 times 0.125 is 0.25. Okay, so now we'll add all this together. 0.25 minus 4.5 plus 21. Ooh, okay, so that is something positive, 16.75. So the thing we learned earlier was if the second derivative is positive at a certain point, then it's concave upward. Okay, and I'm going to skip E again because I don't think you want to watch me do all the mental math and calculating. F should be pretty easy because I'll just plug in 0 and everything is to a power. So that would be 2 times 0 cubed minus 18 times 0 squared plus 42 times 0. All that comes out as 0. So what this told me was that it's neither concave up or concave down, but it's a possible inflection point. Okay, so I'm going to skip 5 too, because it's just like D and F. If you would like more examples, I'm happy to do them on a discussion board. But let's move on to the next bit. Write a written description of the function at x equals a using the information. Then sketch a graph using the information. Okay, so in words, that means the slope is positive at a, or it's increasing at a. Okay, and the second derivative being greater than 0, that's like saying the change in the slope is positive, or the slope is increasing, or it's concave up. So what I do for this kind of problem, because I think concavity is more confusing than slope, I'll start by drawing something that's concave up, and then I'll narrow it down. So I'm supposed to make sure that it's increasing at A. So over on this side, I'd say it's increasing. So I'll just make that so we'll make like an x-axis here, y-axis here, and then we'll put x equals A right there. So it is concave up and it's increasing at that point. So for B, again we have that it's increasing at A. But this time we have that it's concave down. Okay, and then because I think concavity is more confusing, I start by drawing something concave down. And then I'll just pick the side where it's increasing, which is anywhere on the left side. So just draw that down, give an x-axis and a y-axis, and then right there, got something concave down. Part C, so this time it's decreasing at A. And then it's concave up. Okay, and then just as a challenge, this time we'll start with the fact that it's decreasing. So we'll put A right here, and we'll put the point here, and we know that it's decreasing. The thing I need to make sure, though, is that it's concave up. So concave up means that the slope is increasing. So let's see. To make it increasing, we will make it really negative and then make it less negative. So if you think about it, before A, it was decreasing. Really, it's decreasing a lot. Now it's decreasing less and less and less. So, and the picture as I've drawn it does look concave up, so I think I did okay. Okay, a differentiable function where it is, let's see, that's less than 0, so it's decreasing at A. And this time it's concave down. All right, so I got an x-axis and a y-axis, and we'll put our point right here. So it's decreasing yet again, but this time it's concave down, which means the slope is changing negatively. It's decreasing. So if I want my slope to decrease, let's see, decreasing. Slope is changing negatively. So the first thing that comes to mind is I want to do that again, right? Because the slope is negative. But that's not the thing I'm worried about. The thing I'm worried about is the change in the slope. Okay, so let's draw it again. So this is, let's see, something like that. Yeah, that's better. So this is the most positive the slope ever is. Like it's bigger and then it gets smaller and smaller and smaller and smaller. It's a really ugly graph. So drawings here, we have something concave down and it's decreasing right there. So there's kind of two ways to do these problems. I think it's easier to start with concavity and then add in increasing, decreasing. But you can also try to make an argument about how the slope is changing. That actually won't work for part E, I think, because this time we're given that the slope is 0. It's not increasing or decreasing, but you have a slope of 0. And you know that it's, let's see, concave down. Okay, slope of 0 and it's concave down. Cool. Okay, let's pause there.